Hey guys, this video is on the other thing from section 2.1, which is the quadratic formula. A very famous formula, only here we're going to be using it with complex numbers. Okay, so we're going to start seeing the square root of a negative number, which is going to end up saying I in the answer. So we'll have complex roots. Okay, but in case you don't remember the formula, it's x equals negative b plus minus the square root of b squared minus 4ac all over 2a. And some people like to use the song to remember it. You guys won't have to memorize it because obviously you have access to the internet when you're doing your homework and even the test. But the song is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so that's the Pop Goes the Weasel song. Some people use that to memorize it. It's a very useful formula, and what does it do? It actually gives all solutions, to any equation in the form ax squared plus bx plus c equals 0. Okay, the quadratic formula gives solutions to any equation in the form ax squared plus bx plus c equals 0. And this even includes when you have the square root of, say, negative 57. Well, then you would have square root of 57 times I, where I is an imaginary number. Okay, so we're going to be using the quadratic formula to solve equations of this form. And an equation in this form is called a quadratic equation. And it's called quadratic because the highest power is a square, and a square has 4 sides. Okay, that's where quad means 4, and a square has 4 sides, and the highest power is a square. Okay, so what we're going to be using is this formula to solve equations, to solve quadratic equations. So let's see an example of this. Okay, example. Solve for x using the quadratic formula. Solve for x using the quadratic formula. Okay, and at first we're going to start with a relatively simple problem. So problem number 1 is x squared minus 2x plus 5 equals 0. Okay, x squared minus 2x plus 5 equals 0. So the standard way to do this when you're using the quadratic formula is to label what a, b, and c are. So remember, it needs to be in the form ax squared plus bx plus c equals 0. And here we can see that a is going to be 1, and then b is going to be negative 2, and then we can see that c is positive 5. Okay, so a equals 1, b equals negative 2, and c equals positive 5. It's very helpful to just write out what a, b, and c are, either like this, or you can just write them down somewhere. And then you're going to go ahead and write down your formula. Okay, so you write down the formula, and the formula is x equals negative b, x equals negative b plus minus the square root of b squared minus 4ac all over 2a. So when you have that written down, then you're going to go ahead and plug everything in. Okay, so we have x equals negative b, so that's going to be negative of negative 2, right? Because b is negative 2, but it's negative b. Okay, so it's negative of negative 2, negative b, plus minus the square root of b squared, so that's going to be negative 2 squared, minus 4ac, so that's going to be minus 4 times 1 times 5, all over 2a. So that's going to be all over 2 times 1. Okay, so all I did in that step was I took the quadratic formula, which is still up here, x equals negative b plus minus the square root of b squared minus 4ac all over 2a. And I plugged in a is 1, b is negative 2, and c is 5. And notice I was careful to put parentheses around everything. That's always important when you're plugging things in, because especially when you have a negative like this, it's easy to get confused otherwise. Okay, and now we're going to go ahead and simplify this. So let's start with the negative of negative 2. So those two minuses are going to cancel out and give us a positive 2. Okay, so we have x equals positive 2 plus minus the square root of, well, let's simplify this now. Negative 2 quantity squared is going to be negative 2 times negative 2. So this right here is negative 2 times negative 2. Okay, and those two minuses cancel out and give you a positive, and 2 times 2 is 4. So that's going to give us positive 4. And then over here we have minus 4 times 1 times 5. So that's going to be negative 4 times 5 is negative 20. So we have the square root of 4 minus 20 all over 2. And we know that 4 minus 20 is 16. So under this square root, we actually have the square root of 16. Okay? But what's important here is 4 minus 20 is actually not positive 16. It's negative 16. Okay? So we actually have the square root of negative 16, not positive 16. Okay? So whenever you take the square root of a negative number, you'll always have to write I. Okay, so what we do is we rewrite this as the square root of negative 1 times the square root of 16. Because remember that you can split up a square root, and the square root of negative 16 is the same as the square root of negative 1 times the square root of 16. And then we can simplify this. The square root of negative 1 is actually I. That's what we learned about in the previous lecture. And then the square root of 16 is 4. So we actually have I times 4, which is 4i. Okay? So after we do all that, we're actually going to end up with, instead of the square root of negative 16, we're going to have 4i. Okay, so now we have negative 2 plus minus 4i, and then this is all over 2. This is all over 2. Okay, so we have negative 2 plus minus 4i all over 2. And again, how do we get 4i? Well, the square root of a negative number is the same as the square root of negative 1 times the square root of the number. And then the square root of negative 1 is I, so that's how we got that I there. and the square root of 16 was 4, so I times 4 is 4i. So we get negative 2 plus minus 4i all over 2. And then they want you to simplify this. So the standard way to simplify these is to factor out the greatest common factor on the top. So on the top, we're actually going to factor out a 2. So if I factor out a 2 on the top, we have 2 times a quantity, negative 1 plus minus 2i all over 2. And remember, the plus minus means that you have two answers. One of them is going to be a plus, the other one's going to be a minus. But you just treat it as if it were a plus or a minus. And so notice we were able to just factor out a 2, which was a common factor on the top. Okay, now what we can do is we can, to get rid of these 2's, we divide the top and the bottom by 2. So if I divide the top and the bottom by 2, all we're going to have left is negative 1 plus minus 2i. Okay, because those the 2's on the top and the bottom just cancel out. Now, for my math lab, for your homework, they don't want you to leave it as negative 1 plus minus 2i. At the very end, they want you to write both answers. So remember, the plus minus just means you have two answers. And right there, for the first answer, you have a plus right here. And then for the other answer, you have a minus right there. Okay, so our two answers here are going to be negative 1 plus 2i, comma, negative 1 minus 2i. So they're exactly the same setup. The only difference between these two answers is one of them has a plus right there, and the other one has a minus right there. And they want you to separate your answers with commas on my math lab. Okay? So that was a hopefully relatively easy quadratic formula problem. Now in your homework there's a couple more, and some of the other problems have fractions and square roots, so they have radicals that you can't simplify. So I wanted to do another example of using the quadratic formula. And in this example, we're actually going to end up with square roots as part of our answer. Okay, so for this one, our new equation is going to be 3x squared plus 5x plus 6 equals 0. Okay, 3x squared plus 5x plus 6 equals 0. And once again, it has the same instructions. So we want to solve this using the quadratic formula. So here, our a is going to be 3, our b is 5, and our c is 6. Because remember, it's in the form ax squared plus bx plus c equals 0. Okay, and then we're going to go ahead and write down the formula again. So the formula is, the quadratic formula is x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so we wrote down the formula, now we just plug everything in. Okay, so plugging in all these numbers, we have negative b, which is going to be negative 5, plus minus the square root of b squared, so that's 5 squared, minus 4ac, so that's minus 4 times 3 times 6, all over 2a. So that's going to be all over 2 times 3. So all I did in that step was I replaced a, b, and c with numbers. Just plugged everything in directly into the formula. Okay, and then, of course, our next step is to simplify all this. So simplifying here, under the square root, 5 squared is 25. And actually, let me do that in red so it's easier to read. So 5 squared is 25. And then we have negative 4 times 3 is negative 12. And then negative 12 times 6 is actually going to be negative 72. So we have 25 minus 72 under the square root. Okay. And then what's 25 minus 72? Well, if you have trouble with that, you can always use your calculator on your computer, or if you have one on your phone, or if you have a real calculator. 25 minus 72 is negative 47. Okay? So we're going to have negative 47 under the square root. So what we have so far is negative 5 plus minus the square root of negative 47 all over 2 times 3 is 6. Okay. All right, and if you think about your times tables, if you remember your times tables, there are no two numbers in your times tables that multiply to 47. So that means 47 probably can't be factored. Okay. And even if it can, we can't really simplify the square root. So we're just going to leave it as 47. So what are we going to do next? Well, we're still going to split up the square root into two parts. You got the square root of negative 1 is your first part of your square root, and the square root of 47 is the second part. Okay, because remember, the square root of negative 47 is the same as the square root of negative 1 times the square root of 47. Well, what did we say the square root of negative 1 was? Well, we said the square root of negative 1 is the imaginary unit I. So that's just going to be I. And then, like I was saying, 47, you can't really factor it. Your times tables don't have 47. So you just leave it as the square root of 47. So we're actually going to have I times the square root of 47. Okay, and that's as simplified as it gets. So what do we have now? We still have negative 5 plus minus, but now we have I root 47 all over 6. Okay, so down here we have negative 5 plus minus I root 47 all over 6. Negative 5 plus minus I root 47 all over 6. Okay, and once again, they want you to write this as two separate answers. Okay, and you want to split up the fraction into two parts. So if I distribute the 6 to each denominator, we're going to have two fractions now. So we're going to have negative 5 over 6 for our first fraction, and then we're going to have plus minus. And then for our second fraction, we have root 47 all over 6. And then don't forget, we also have an I here. And for the I, we want to bring it out front. So I'm going to bring it over on the right side here. Okay? So we actually have negative 5 over 6 plus minus the square root of 47 over 6 times I. And then all we have to do is, in our last step is the plus minus means we have two answers. Okay? So we split it up into two answers. We write exactly the same thing. It's just one of them has a plus right here, and the other one has a minus right here. Okay? So our two answers are going to be negative 5 over 6 plus root 47 over 6 I. And then the other answer is going to be negative 5 over 6 minus root 47 over 6i. Okay, so negative 5, 6 plus root 47 over 6i, comma, negative 5, 6 minus root 47 over 6i. So exactly the same thing, it's just one of them has a plus there, the other one has a minus there.